I'm Katie Lindeman. I teach honors chemistry and honors physics at Lindeman Math and Science, a Chicago public high school.
Hi, and I'm Carole Namowicz, and I teach chemistry, both honors and AP levels, also at Lindeman Math and Science Academy. Again, it's a CPS school. The unit that we're going to do an overview of today is a unit on kinetic molecular theory. You see the underlying lessons here on the screen behind you, and we're going to go through two of the CT tools that we're utilizing within this unit. The first major tool that we use beyond just students working with simulations and such is we're using a net tango, which is students using actually trying to program themselves in NetLogo, and it's made into these blocks, which makes it really easily digestible for students who have never programmed before. So essentially, they see here, they'll see a little video for how to do it first, but if they go down to the bottom of the screen and they go setup and then go, they see these particles moving around, and they should notice that the particles themselves are not behaving as gas particles, so they'll go down to the bottom, and within here, they will change how those particles are behaving. As soon as they make a change, they'll need to go to the top and recompile. But it's a way, again, it's a way to make programming more accessible to students that haven't necessarily had computer science before or done any programming. That's the first major CT tool. Another major tool that we're using within the unit is actually at the end of our unit, and it's a simulation that's been designed by Umit, and it's new and it's still in the beta stages here, but we're getting a lot more data in. So it's meant to be a can crusher simulation. This unit is based around this can crush of taking a can with a little bit of water, an aluminum can, putting on a hot plate, putting in the ice bath, it crushes. And that's what this is simulating. It's a lab that we would like to do in our classroom. This year we won't be able to, but we're putting the can on the hot plate here, allowing it to heat up, heat up, heat up, heat up. And then we bring it over here and hold it upside down. And if it's been sitting on the hot plate long enough, it should crush. Now, that did not show the microscopic version of what's happening, which obviously is something we want students to see. So you click see inside, and then what we can do is run it again, but now students can see the particles inside. And that's really a goal here, is for students to connect the micro and the macro. So I'm gonna let Katie go ahead and take it, and I'm gonna stop sharing. So go ahead, Katie.
Yeah, so this unit, students will be practicing the skill of modeling microscopic gas particle interactions to explain the macroscopic behavior of gases. And this interaction between microscopic and macroscopic shows up in every single unit that we have throughout the course of the school year. Also at the end of the unit, students should be able to describe the motion of gas particles and predict how changing one or more variables will impact a system of gas particles.